In this way, if we find two angle of elevation, we can find the height of the tower as well as the distance from a particular point on the ground. In the similar way, if a tower is shown standing on a cliff, this is the cliff and there is a tower standing on the top of the cliff, the angle of elevation of top of tower, angle of elevation of top of tower and cliff from boat. This is the boat, and angle of elevation of top of tower from cliff and top of the tower, and this is top of cliff. We know these two angle, then we can find the distance of boat from cliff. This distance, as we have done in previous example, we can find distance length of the cliff as well as distance of boat from the cliff. Next example, from the top of a tower 10 meter. So, this is tower whose height is 10 meter. From top of this tower, the angle of depression of the top and bottom of a house are 30 degree and 45. So, there is a house. So, when we look from the top of the tower to the house, when we look at top of the house, the angle of depression is 30 degree, and when we look at bottom of the house from top of the tower, the angle of depression is 45 degree. Now, we have to find height of the house and its distance from the tower. Now, take PQ as tower and AB as house. Now, PQ length is given as 10 meter. Now, take perpendicular from A which meet PQ at point M. Now, consider this triangle BPQ. BPQ with angle is 45 degree. So, as angle is 45 degree, so PQ is same as BQ. Perpendicular is same as base when angle is 45 degree. So, PQ is same as length BQ. So, this BQ length is equal to 10, as PQ length is given as 10. So, distance of tower from the house, distance of house from the tower, that is equal to 10 meter. Now, we will find height of the house. Now, to find height of the house, consider triangle PAM. So, this triangle PAM angle is 30 degree. This is right angle triangle. So, we take the help of trigonometry. So, here PM by AM, that is equal to tan 30 degree. Here perpendicular is PM and base is AM. So, PM by AM is equal to tan 30 degree. So, PM is equal to AM tan 30 degree. We will put value of AM because AM is equal to BQ. We have find that BQ is equal to 10 meter. So, AM is also equal to 10 meter. So, we will put value of AM 10. So, PM is equal to 10 times tan 30 degree, and we put value of tan 30 degree 1 upon 1.732, we will get PM as 5.77 meter. So, PM as 5.77 meter. So, we know length of PQ, we know length of PM, we have to find height of house AB. AB is same as MQ. So, MQ is PQ minus PM. So, MQ is equal to PQ minus PM. We know both length PQ as well as of PM. PQ length is given as 10 and PM length we have find that PM is equal to 5.77. So, length MQ is equal to 4.23 and height of the house is same as MQ. So, height of the house is equal to 4.23 meter. So, if from top of the tower angle of elevation of top of house as well as for bottom we know, then we can find height of the house as well as its distance from the tower. Next example, a 1.5 meter tall boy, this is boy 1.5 meter high, BD, let BD is Y, is standing at some distance from 30-meter tall building. This is AF is 30-meter tall building name AF. The angle of elevation from his eye to the top of the building. So his eye is at B, from his eye to the top of the building. AF is building, so its slope is at A. Find from B that angle of elevation is 30 degree, and it increases from 30 to 60 degree as he walks toward the building. When he walks from B to BD to here this place, here from D to E, then he find when he is at BD, angle of elevation is 30 degree from top of the building, and when he is at E, he find the angle of elevation as 60 degree. Find distance he walked toward the building. We have to find the distance B, and here distance point where angle is 60 degree. We have to find this distance from B to this point where angle of elevation has changed from 30 degree to 60 degree. So let name this point as BM. So we have to find distance BM. Let AF is building and BD is the position of the Y. So we have given that AF is equal to 30 and BD as 1.5. These two distances we have given and two angle of elevation. Now first distance AC, because BD distance is same as CF distance, so and AF distance is given, so we can find distance AC. AC is equal to AF minus CF. So equal to AF minus CF is BD. So 30 minus this total distance 30 minus 1.5, we will get distance AC. So AC is 28.5. So in triangle consider this triangle ACM, right angle triangle. Here AC by CM, this is tan 60 degree, and tan 60 degree value is equal to square root 3. We will put value of AC. We have found that AC is equal to 28.5. When we will put value of AC, we will find CM as 28.5 by square root 3. Now CM is equal to 28.5 divided by 1.732, that is equal to 16.4. Now we have find the value of CM, but we have to find BM. Now consider this triangle ACB. Here angle is 30 degree. Now this is also a right angle triangle ACB. So AC by CB is equal to tan 30 degree. Value is 1 by square root 3. So because AC is given, we have find that AC is equal to 28.5. So 28.5 divided by CB is equal to 1 by square root 3. So simplify it, we will get CB as 28.5 multiplied by 1.732 value of square root 3. So multiplication gives 49.5. So CB distance is equal to 49.4. Now we know distance CB, we also know distance CM, but we have to find BM. BM is CBC minus MC. So BM is equal to CB minus CM. So this length of BC we have find at 49.4, and length of CM we have earlier find that this is 16.4. So it will together become 33. So the Y walked distance B from M, angle of elevation changed from 30 degree to 60 degree. So this distance is equal to 33 meter. Next example. The upper part of a tree, this is the tree PQR, this is the tree. The upper part of a tree broken over by the wind makes an angle of 30 degree with the ground. The upper part of the tree, due to wind, a tree broke into two parts, and upper part falls down on the ground, which makes an angle of 30 degree with the ground, and it fell down with the at a distance of 40 meters. So PR distance from the top of the tree, and from the foot of the tree distance is given as x is equal to 40 centimeter. What was the height of the tree? So we have to find initial height of the tree, that is equal to PQ plus QR. Now we have given angle of elevation 30 degree, we have to find length of the tree. Now let PR be tree, PQ plus QR, that is the tree, and QR be its broken part fallen on the ground. Now here distance x distance is the distance of top of tree from the foot of tree. This is given as 40 centimeter. We have given this distance 40 centimeter, and we have to find the distance PQ plus QR, that is height of the tree. Now height of the tree, that is h, we name h, that is PQ plus QR. Now in triangle, consider this triangle PQR. This is right angle triangle, and the angle is 30 degree. Again we take the help of trigonometry to find this distance PQ plus QR. Now we have given PR, we will make use of this distance PR. We PQ by PR, that is tan 30 degree, perpendicular by base. And also we want to find QR, so QR by PR, that is equal to secant 30 degree, because hypotenuse by base is equal to secant 30 degree. Height of the tree is equal to h is equal to PQ plus QR. So PQ is equal to PR tan 30 degree, and QR is equal to PR secant 30 degree. And we have given value of PR. PR is equal to 40 degree, 40 meter length, 40 centimeter, 40 centimeter, and tan 30 degree, put the value of tan 30 degree 1 by square root 3, plus again put value of PR 40 centimeter and secant 30 degree 2 by square root 3, reciprocal of cos 30 degree, that is square root 3 by 2. So this is 40 multiply by square root 3, that because when we add this 2 plus 1 3 by square root 3, 3 by square root 3 means square root 3. So when we multiply 40 by square root 3, we will get 1.732, put value of square root 3, we will get 69.3 centimeter. So height of the tree is equal to PQ plus QR, that is 49.3 centimeter. So in this way we can find height of the tree. Again this is, look at this tree, this is the eyes of the observer, and but height of the tree is little down from the eyes of the observer. The horizontal line from the eyes meet the tree at this point. So if we want to find height of this tree, that is equal to A plus B, we have take the help of these two triangle, first where angle is A degree, and second right angle triangle where angle is B degree. So here A, this height A is equal to A by D. If this distance is D, distance of tree from the eyes of the observer, if this distance is D, then A by D is equal to tan A degree. So then A is equal to D tan A degree. And again similarly we take the help of this triangle where angle is B degree. This is again right angle triangle. So B is equal to D into tan B degree. So tree height is equal to A plus B. So we will add these two heights to get height of the tree, that is equal to A plus B. So in this way we can find height of the tree. The Great Pyramid, which is at Giza near Cairo, one of 7 wonders of the ancient world, the only one still surviving. This is the one of the earliest use of trigonometry. We have used trigonometry to find the height of this Great Pyramid, otherwise it is not possible to find this height, but with the help of trigonometry we can find these distances and heights and distances. So this is the use of trigonometry. Mostly we use trigonometry to find those heights which are inaccessible. Thank you.